Good afternoon, everybody. My name is Alex Lucas. I'm the Business Development Manager for Laser Scanning Products at Nikon Metrology. I'm here to give you a brief presentation on the latest advancements within our laser scanners. We're located over at booth 500 today, so please feel free to stop over. We have a few different laser scanning technologies under our umbrella to be able to show off here today, so please feel free to stop over and pay us a visit. So just a very brief agenda again of what I wanted to run through the next few minutes here. Obviously the advancements within our laser scanners, for anybody that may have been familiar with laser scanners in the past, they've come quite a long way from where we were at 2, 3, 5 years ago. The new generation of scanners capable of getting anything from shiny materials to dark and multicolored surfaces with the greatest of ease. So jumping into our CMM scanning portfolio, we have a few different laser scanners that we're able to provide. The LC60Dx is the workhorse of our laser scanning offerings on the CMM. Being able to collect points at a rate of about 75,000 points per second is a blazing rate. Especially when you consider 75 stripes per second. What that equates to is the start and end point of any given scan is going to be able to go through and process quite a bit faster than conventional old CCD analog technology. We also have our Xtreme scanner. So this is the scanner that we actually have on one of the CMMs in our booth here today. The Xtreme is a patented multiple stripe, multiple laser scanner within our portfolio. It's ideal for picking up a variety of features. So if you have circles, slots, and even things as simple as planes, the Xtreme with 3 lasers is able to pick up quite a bit more information than a conventional single-stripe laser scanner. We also have that same Xtreme scanner in a long standoff variation. So when you imagine that you're scanning around things like fixtures or difficult things to maneuver around a CMM, having a long standoff variation makes it ideal to be able to not crash into the part. I think we've all probably been there if you come to programming a CMM, of having some close calls. So with the long standoff variation, you're about 8 inches away versus 4 inches away from the target surface that you're trying to pick up data on. So ultimately what that comes out to is a better reaction time frame if anything were to happen inadvertently. And then rounding out our CMM scanning platform is the LC60Dx. So this is more of an entry-level laser scanner. The LC60Dx is great for people that just are new to laser scanning, maybe even new to CMMs. It doesn't have as high-level specs as the LC60Dx, but at a more affordable price, it could be a better way to transition into what laser scanners are able to offer to your facility. So moving over to our handheld laser scanners, we have, again, 4 different models that I wanted to point out. So first off, our MMDx 50. The MMDx 50 is a great scanner when it comes to picking up high resolution areas. So there's a very tight point spacing and it's a very accurate probe. This particular scanner can be mounted onto an articulated measuring arm or an optical CMM. Either one of those we both have represented in our booth over, again, booth 500 to be able to take a look at. But the MMDx 500 has a very narrow field of view. We have a couple more additions to the MMDx lineup that come in higher variations as far as size. So the MMDx 100 has a 4-inch wide stripe. So across that stripe, you're able to pick up the same number of points, so the resolution will not be as great, but with a wider scanning envelope, you're able to get quite a bit more data and coverage of a given part. Rounding out the scanning portfolio for the MMDx scanners is the MMDx 200. So this is the newest addition to the lineup. Again, you can see all the MMDx scanners are going to scan at the same 80,000 points per second and up to about 150 stripes per second. But with the case of the MMDx 200, that's going to be a 200 millimeter wide or an 8-inch wide stripe. So you can imagine the swath of data that you're able to scan in a given pass over any area that you're trying to collect data on. Going over an 8-inch area means you're just getting more of that part digitized in a shorter amount of time. And then finally is our LC60Dx scanner. So it's capable of being retrofit on an ARM as well as going on the CMM. You know, we do have a handful of customers across North America and Europe that have embraced laser scanning technology and have seen the ability of putting an LC60Dx laser scanner on either a portable device or a fixed bridge CMM as a great way of jumping into the technology. You know, it's not the initial buildup in capital that they had to spend. To have a scanner for each of those two devices, one scanner can go on two platforms seamlessly. And then when it comes to our software portfolio, we're very proud to offer a wide range of software. In the cases of many of these software packages, we can scan in with our MMDx laser scanner on either our ARM or K-scan system or optical CMM directly. So there is no third-party intermediate step as far as collecting that scan data. We can go directly from our laser scanner into any of these software packages, or of course our own focus inspection software directly. So there's no middle step of the process. We're taking point cloud data and we're analyzing it quickly after that. So one of the biggest, latest advancements within the scanners, again, I referenced our ability to improve on picking up scan data on difficult to scan surfaces for previous generations of our laser scanners. So in the old scanner, I use that as a broad umbrella term. Maybe you're looking at something that has a lot of reflectivity. You know, the example that we use here is that dog water bowl. And then we have a dark-colored automotive fender as well. So two surfaces, typically either a laser would be absorbed by or reflected off of too greatly to pick up any scan data. So what that meant is you're going to collect poor scan data. So there's a few ways of addressing poor scan data. The most common method, I think everybody that's familiar with laser scanners has come to know and either love or despise Magnaflux Spray Developer. A great tool, but it can be messy and it can be difficult to work with, both applying that to start the process and removing it once you're done with a scan. Thankfully though, applying some sort of a spray powder to take away the shine or make more of a friendly scanning surface available does give you a good resultant scan data. Comparing that next to the LC60Dx, MMDx, or any of our digital laser scanning platforms, it's a one-step process. There's no middle step of having poor scan data. Ultimately, you can eliminate the poor scan and eliminate the spray going from either a shiny part or a dark part to a completed scan. And again, I think the proof is in the pudding. You know, we're here at least for the remaining hour of the show over in our booth to be able to give you guys a first-hand understanding of what the scanners are capable of achieving. But whether it's a shiny part, a difficult to scan surface, a multicolor surface, the technology that we've put into our line of MMDx and LC60Dx laser scanners has really come quite a far way in addressing those difficult to scan areas. And ultimately, we like to throw that logo around. You're eliminating the scans, that spray altogether, and really that shrinks the cycle time. You don't have to prep a part, you don't have to remove any of that spray after it's done scanning. A few advantages of laser scanners next up. Measurement coverage is obviously a huge advantage, and it comes in three different forms. If you look at the three conventional ways of taking discrete point data, at the bottom, working our way up, we have a conventional touch probe. You're taking a point of data a second if you're really going very quickly. Comparing that with an LC60Dx or an MMDx laser scanner, you have entire swaths of data that you're collecting scan data from. The analogy that we like to use is painting a part. You're creating essentially a digital image of the part that you want to inspect or reverse engineer. All of the scan data is going to be collected within the software for all of your post-processing. So the more scan data across a larger area that you can collect, the more it's going to lend itself to giving you a good concrete idea of how a part either deviates or how you need to reverse engineer a part to make it conform to what you want it to be. Speed, obviously we're taking tens of thousands of points per second. Whether it's on a CMM or a handheld laser scanner, we're able to go through, collect insurmountable amounts of data for just even 3-5 years ago. Within the latest generation of point cloud softwares, it's not at all an issue for them to be able to take this many points and even more. The ceiling, especially with 64-bit processing machines, is nearly unlimited. Really restricted to the size of your hard drive to be able to access those points and do anything analytical with them, as far as comparing them to a CAD model or creating surfaces from scratch. Another big advantage is offline inspection. We're not here to advocate the fact that you have to have one PC both running a CMM in an ARM and creating your analysis. You can have a CMM and your inspection PC completely separate. Kind of graphically showing that, if you were to go through and have a CMM scanner collect data off of a part, say maybe 6 minutes to be able to do the scanning and the inspection. If you separated those into 2 different PCs, we can do the scanning on one machine, do the inspection on another machine, and then have the same report generated in half the amount of time. Essentially, doubling your throughput just by separating that onto 2 different PCs. Another advantage is how quick and simple the scanners are to retrofit. Whether it's one of our own line of CMMs or a third-party CMM, our own ARM or optical CMM, or a third-party system, we can put our scanners on a variety of different models and configurations. There's a few parameters that we need to make sure are in place in the case of a CMM or an ARM as far as model compatibility, but it's something that we're more than happy to be able to work with you on to figure out what is the best way of getting to the point of having a scanner retrofit on your existing metrology equipment. Another huge advantage is creating easy to understand reports, and this is one of my favorite. Ultimately, a picture tells 1,000 words. It's an old adage, but it definitely holds true. Comparing the 2 different reports that you might expect to see from a metrology system, on the left-hand side, you have a traditional touch trigger inspection report. In the hands of a quality engineer or manufacturing engineer, that contains all the data that he may need to be able to understand how a part looks and how it deviates. You have a tabular structure, you see the deviations with respect to tolerance, and it tells you everything that you need to know for that small subset of control points that you're looking to analyze. On the right-hand side is a typical inspection report that we would create within our own focus inspection software. So within the right-hand side with our focus inspection software, not only do we have the tabular data on the right-hand side, again, creating a simple, quick pass-fail or a pass-fail condition, but we also have the graphical feedback. So you can see instantly not only the discrete points that you want inspected, but the entire format for how a part looks and deviates with respect to the nominal data it's compared against. So it's a huge advantage when it comes to not only a manufacturing engineer, but maybe higher up. Instead of a managerial type looking at this report on the left and not having any idea what they're looking at, the color inspection report on the right gives them a good idea of how accurate the part is and how well it was manufactured to spec. So some typical applications for the laser scanners, they come in all different varieties. Medical is a relatively new addition thanks to some of the improvements that we have in our scanning technology. In previous iterations and generations of our laser scanners, things like for the medical industry that were shiny and difficult to scan were just impossible for us to be able to hit. Something in the case of this orthopedic knee implant, it's a very highly reflective surface, but our scanner is able to get through that with all the technology that we put into the scan head and create clean, concise scan data to compare back to CAD nominals. Injection molded plastics. So things typically for plastic parts, they might be a little bit more fragile, a little bit more susceptible to operator influence if you're taking a manual hit with a tactile probe on a plastic part, or just some sort of a deflection if you're taking a touch trigger hit on a CMM. With a laser scanner, you don't have to worry about that. With a scanner, you can put the part directly on the CMM, go over to collect your point cloud data, compare it back to CAD nominals, and not worry about any deformation in the part, whether it's from the probe that's taking the points or from fixturing that might be skewing it from how you want it to be scanned in a free state condition. Sheet metal components, this is really the bread and butter for what the laser scanners were designed around. Taking sheet metal, typically something that has both discrete features like circles and slots that you want to be able to go through and query very accurately, but also free-form surfaces that you want to get profile dimensions off of as well. So with the laser scanner, you get both. Again, you can see from the report there, we can drill down a step further to pull out discrete XYZ points and call out dimensions from there, or just have the overall three-dimensional color map showing all the deviations within the part itself. Castings, another great example of what scanners are capable of providing feedback from. Obviously in the case of castings, it's a very friendly surface for us to be able to scan. But oftentimes the case with castings is you'll have a combination of both rough surfaces and machine surfaces. So in those situations, again, with our digital scanning technology, it's not at all a problem to be able to pick up points off of both shiny surfaces and as-cast surfaces. Another plug for our booth over in 500 to take a look at exactly how we can collect data on any surface regardless of its finish. Turbine blades, another advancement in our technology, being able to have a scanner that's accurate enough to be able to pick up the leading and trailing edges for certain features, such as turbine blades, is relatively new to the lineup, but we've been generating great results. For pieces like turbine blades, you want to make sure that you're scanning at the highest of accuracy. And compared to the traditional method of taking a few sections across the foil itself and maybe a few probed points on the root, our value proposal is scanning the entire blade. Don't look at a small subset of how the blade behaves. Scan the entire part, archive it if you want, but generate a report on all of the scan data, not just a smaller portion. And then miscellaneous, general manufacturing, basically anything out there that can be scanned, we like to scan it. Obviously here it's a front end of a NASCAR vehicle. We have a NASCAR vehicle hood in our booth courtesy of Joe Gibbs Racing. So ultimately there's a lot of different applications out there, a lot of different venues for using laser scanner. Looking at even how the technology was about 5 years ago, it was more of an artistic thing. We had scanners in many design and research environments. Maybe automotive OEMs were scanning clay models and generating surfaces from that. Nowadays, the scanners have transitioned into more of an inspection tool because of the accuracies that we're able to perform. So a brief application discussion. I mentioned how injection molded plastics and something that's smaller, a little bit more intricate, we've been showing great results on being able to pick up scan data. So here you have pictured just a tape dispenser. What might not seem to be a very complex part caused a lot of problems for a particular customer of ours. So we had to go back through and scan this to see how things fit together. They were very concerned with the top and the bottom of this particular piece not coming together cleanly. So they had to see where the interference areas were. So they could go through and create a touch probe routine, either on a CMM or a hard probe, to be able to create specific XYZ comparison points. Or, with the case of the laser scanner, you'll go through, take your model, scan it to create a point cloud, and then convert those points into a polygonal mesh. Once you have the mesh, which we were able to construct in less than 5 minutes through our automated scanning routine, we can compare it against the model information and create a three-dimensional color map. And ultimately, after the case of an automation routine, we can typically get a lot of automated inspections down to taking less than 1 minute to perform. Again, this is examples that we have all throughout quite a few projects that we've worked on. But in the case of this particular customer, that color map gave them all the information that they needed to know in order to modify their die process and their rework process to make sure that they were making parts that would accurately and cleanly mate together. That's everything that I wanted to touch on today. I know I'm running short for time. I don't know if I've chewed up all the opportunity for questions, but again, we're here at least for the next hour over in the booth. I have a few flyers up front here for a special show promotion that we're running as far as a arm, a scanner, and the inspection software to be able to run it, at least a special that we're running through the end of the year. So feel free to come up, grab a brochure, or feel free to stop by at our booth in the back. Again, my name is Alex Lucas. Any more questions, just please let me know.